Hello, my topic for presentation is creating AWS Cloud Formation templates using JSON and YAML. So, welcome to this presentation. My name is Yash Sachdev, and today we'll explore how to use these formats to define and manage your AWS infrastructure. With introduction to AWS Cloud Formation. So, what is AWS Cloud Formation? AWS Cloud Formation is a service that enables you to model, provision, and manage AWS resources using code. It automates the process of setting up and configuring AWS resources, ensuring consistency and reducing the potential for human error. The benefits of AWS Cloud Formation are as follows, like automation, automate the provisioning and updating of your infrastructure, consistency, ensure that resources are consistently configured across environments, version control, use version control to track changes and collaborate on infrastructure definitions. AWS Cloud Formation supports defining template using JSON and YAML formats. So what's the difference between JSON and YAML? Let's talk about the JSON first. It provides verbose syntax. JSON is more verbose and can be harder to read for large templates. Strict format requires strict formatting and punctuation, such as commas and quotation marks, etc. It is widely used, commonly used in APIs and web applications. Let's talk about YAML now. Its syntax is very readable, like it's more readable and concise, making it easier to write and understand. Flexible, flexible format, less strict formatting rules, which can reduce syntax errors. Configuration files, frequently used for configuration files due to its readability. So now let's talk about the basic structure of CloudFormation template. A CloudFormation template consists of several sections, each serving as a specific purpose. Template sections. Description: a brief explanation of the template. Parameters: define values that can be passed in at runtime. Resources: the AWS resources to be created. It is a mandatory section. Outputs: values to be returned after the stack is created. Let's take an example. You can see here the JSON code. So first we will define AWS template format version, then description, describe whatever it is, then resources. And the second one is YML. In YML, this is what the format is like. Here is an example of a basic cloud formation template in JSON that creates an S3 bucket. So first, the AWS template format version, description, resources. And resources, inside resources, my bucket, type of bucket, AWS S3 bucket. Here is an example of a basic cloud formation template in YML that creates an S3 bucket. So first, AWS template format version, description, resources. Inside resources, my bucket. Inside my bucket, the type of the bucket you want to create. So here we are taking the S3 bucket. This template specifies the creation of an S3 bucket without any additional properties. Head, we are talking about the parameters section. The parameters section allows you to pass values into your template at runtime, making it flexible and reusable. Purpose: customize templates without modifying the template code. Let's take an example. So it's a JSON example. First, we will take parameters. Inside parameters, bucket name, type, string, description, whatever the description you want to give, name of the S3 bucket. Only for YAML, the syntax is like this: parameters, bucket name, type, string, description, whatever description you want to give, name of the S3 bucket. This defines a parameter named bucket name that accepts a string value. So using properties in resources. Parameters can be referenced in the resources section to dynamically set properties. Example of integrating parameters: JSON. And JSON, this is the code resources my bucket inside my bucket type. We are creating S3 bucket. So AWS S3 bucket properties bucket name. Similarly, this is the code for YML. Resources my bucket type AWS S3 bucket since we are creating S3 bucket properties bucket name. This example shows how the bucket name parameters is used to set the name of the S3 bucket. Resources section is the core of the CloudFormation template. It defines the AWS resources that will be created. Its purpose is specify AWS resources and their properties. Let's take an example in JSON. So first resources my EC2 instance since we are creating an EC2 instance type AWS EC2 instance properties instant type t2.micro. Let's take instant type st2.micro. Similarly, this is the code for YML. It's very easy compared to JSON. Resources my EC2 instance type AWS EC2 instance, whatever the properties you want to give to the EC2 instance. For example, we are taking instant type as t2.micro. Output section declares values that you want to return when your stack is created. These values can be used to import into other stacks or for display purpose. Return values from the stack for further use. Let's take an example in JSON. Outputs, bucket name, description, whatever the description you want to give to the bucket. For example, the name of the S3 bucket, value, reference my bucket. Similarly, this is the code for YML. Outputs, bucket name, description, the name of the S3 bucket, value, reference my bucket. So we can clearly see it's very easy in YML. It's very readable. This outputs the name of the created S3 bucket. Detailed example of the output section in JSON that outputs the name of the S3 bucket. Similarly, in YML, this example returns the bucket name as an output value. Let's talk about the best practices. So to ensure your cloud formation templates are effective and maintainable, follow these best practices. Version control. So we should track changes to your template using version control systems like Git. Validation. Validate templates before deploying using tools like the AWS CLI or CloudFormation linter. Modularization. Break templates into smaller, reusable components to simplify management and reuse across projects. Documentation. Add comments, descriptions to template to make them easier to understand and maintain. So, what are the tools and resources required? There are several tools and resources available to help you create, validate, and manage CloudFormation templates. For example, let's talk about the AWS CloudFormation Designer. It's a visual tool for designing and editing CloudFormation templates. AWS CLI, command line interface for managing CloudFormation stacks and validating templates. CloudFormation linter, a linter tool to validate CloudFormation templates against this specification. Let's conclude the presentation. So let's summarize whatever we have learned. We have explored how to create AWS CloudFormation templates using both JSON and YAML. We discussed the structure of templates, including the parameters, resources, output sections. We highlighted best practices for managing and maintaining CloudFormation templates. Very much.